Welcome to another Mr. Paul video, and today we're talking about 10.1 properties of translations. Now, if you haven't watched the previous video, translations is another word, a math word, for slide. Okay, so when we say translation, we mean to slide. And we're going to be sliding, also known as translating, objects, shapes. This is one of three different types of transformations. Now, transformations is the math word for movement. So just be careful. Translations sounds a lot like transformations, but they don't mean the same thing. Translation means slide. Transformation is a movement. Okay? Now, remember, on paper, we are working with objects, and it looks a little bit different than grabbing, for example, an index card. What we're going to be working today is how to slide an index card. So for example, if I have an index card that looks like this, I'm going to slide it to the left, or I'm going to slide it up, slide it back down, slide it to the right. The way we demonstrate this on paper is a little bit different than as if we were to grab a card and then visually show it. So what we're going to be doing on paper is taking snapshots of what it looks like before and then what it looks like after. So for example, if I take this as a before picture and then after is over here, it's safe to assume that the object slid to the left. Or likewise, if it starts down here and ends up here, it's safe to assume that it slid up. So in this video, we will be discussing how to demonstrate this on paper. So to start off with, the first snapshot that we will be taking is going to be its starting point, and that's called the pre-image. The pre-image is the math word for, hey, this is the picture of where it started. And it's going to be labeled by A, B, C, D. Any of the regular letters will demonstrate that this is the starting image, the starting object. The ending will be called the image. Okay, so pre-image is before and image is after, and it's labeled with A prime, B prime, C prime, and D prime. Now, in the previous video, we discussed these apostrophes are called prime when talking about the ending location of an object. And to move a shape, we're going to move each corner of the shape. And that will be demonstrated in this video. So let's just say we have a triangle that looks like this. Okay, the triangle that looks like this, and we'll label the corners A, B, and C. It's labeled A, B, and C because it's the starting location. It is the pre-image. This is the pre-image. And what we're going to be doing is moving this object like this, where this will be 4 units to the right. We will say that this is 4 units to the right. Now, if we want to move this object, we can't just grab it, right? It's a whiteboard. It's a piece of paper. So what we have to do is just move this entire object and then take a snapshot of where it should end. Now, to do that, we need to move the entire object. But we can't just grab the center and move the object because some objects are harder to see. Some shapes don't have a direct center. So instead, we move each of the corners, meaning A, to A prime. But it's going to follow the same characteristic, meaning 4 units to the right. Let me demonstrate. If I take A and move A 4 units to the right, we'll say that this distance is 4 units to the right. I'm going to imagine that I moved A 4 units to the right. So this distance will be the same as this. And this new location from A to where A would end is now called A prime. Where A started is A, where A ended is A prime. I'm going to also move B the same distance. Okay, this would be 4 units to the right. And this will become B prime, right? Starts at B, ends at B prime. And C will move the same fashion, the same length, and become C prime. Now, A, B, and C primes are what make up the image. If I connect the dots, this is known as the image. If each corner takes the same characteristic as the movement I'm trying to imitate, I will have successfully, on paper, moved the pre-image to the new location called the image. Similarly, if I had a rectangle, let's just say I have a rectangle like this. Okay, it looks more like a square, but that's okay. With A, B, C, and D. This is the pre-image. And in this example, I'm going to move it, say, 6 units down. And we'll say that this distance from here to here represents 6 units down. So both A, B, C, and D is going to follow the same exact characteristics, and we are going to move it down this length. So we'll start with C, for example, and we'll just count down 6 units, roughly speaking. So it's like 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, this will be C. This is now C prime. D will follow the same idea down here. This is now D prime. A will follow the same characteristics and become A prime. And B will follow the same characteristics and become B prime. I've moved D to become D prime, A to become A prime, B to become B prime, and C to become C prime. Now, this one's a little crooked. I could fix that a little bit. Let's fix that a little better. Okay, something like this, B prime. But the idea is that when we connect the dots, we would have recreated the pre-image down here to the ending point, and it's now called the image. On paper, we've demonstrated that the shape can be moved down by giving snapshots of the before and after. Now, this is how we demonstrate it on paper. Typically, we would demonstrate it on graph paper. Obviously, over distance learning, that graph paper is not easily available to all students. Okay, so this is merely a picture of what we would be doing. On graph paper, we can actually count down 6 boxes. We can count down 6 units better. So typically, this shows up better on graph paper, but this is good enough for a conceptual understanding. I hope these videos help. That's all for today's video. Peace.